Next, we'll discuss another method for root finding, which is one of the most popular. So it's called Newton's method. Newton's method can be thought of as a variation of a fixed point method where we select a particular g of x. The idea of the Newton's method is very simple. We just approximate our function with its tangent line. So let's say if I have some function like this, we are looking for the root in this case. Instead of looking for the root of f, we start with some point x0, right? So, and we look for the root of its linear approximation given by the tangent line. And this is exactly the linear approximation that we get from the Taylor series expansion. So by Taylor series, f of x is roughly f of x0 plus f prime of x0 times x minus x0. Okay? And now instead of solving for f of x equals to 0, we'll look at this approximation equal to 0. The equation that we get will be f of x0 plus f prime of x0 multiplied by x minus x0 is 0. So we'll have f prime of x0 times x minus x0 is minus f of x0. We divide by f prime of x0, assuming that it is not 0. And as a result, we'll have x is equal to x0 minus f of x0 divided by f prime of x0. So this will be our point x1. This will be the new approximation of the root. All right, so geometrically, this is the point here. Okay, so this is the root for the linear approximation. Then again, we proceed in the same way. So we find the approximation at the point x1 with the tangent line, so we get x2 and so on. Okay, so we see that the Newton's method converges very quickly. So it is extremely fast. So if we start with the right point, which is close enough to the root, and the root in this case is here, then the method converges much faster typically than the other methods that we discussed so far. So that's why whenever the Newton's method works, it's preferred to other methods. But of course here you need to have the derivative, right? You need to make sure that the derivative is not equal to 0. We need to start close enough from the root. It's sometimes hard to predict what close enough means, okay? Let's look at an example of application of Newton's method. A very simple example. So let's say, you need to compute the square root of 8 and you don't have a calculator with you, and you need to do it by hand and quickly. So you need to have a reasonably good approximation. How do we do this? The square root of 8 is the solution of the equation x squared is equal to 8, right? So which is the same as x squared minus 8 is equal to 0. So if you look at f of x equal to x squared minus 8 and apply the Newton's method, we can have a very good initial guess here. So 8 is close to 9 and square root of 9 is 3, right? So let's start with the point 3. So let's consider x0 equal to 3. The Newton's method in this case will be xk plus 1 is given by xk minus f of xk, which is xk squared minus 8, and divided by f prime of xk. So f prime of xk will be just 2 times xk. All right, so this is our iteration. So to compute x1, you take x0 and plug it in this formula. So you'll have 3 minus 1 divided by 6. So this will be 3 minus 1/6 is roughly 0.17. So it's roughly 283. So, and it's already a reasonably good approximation of the square root of 8. All right. Say if I go to Excel to compute square root of 8, it's actually roughly 283. So we can see that even one iteration of the Newton's method gives a very good result in this case.